Okay, so section 5.3, we are going to evaluate integrals. And so here's our integral. So integral from 0 to 4 of 4 over 5 t cubed minus 3/4 t squared plus 2/5 t dt. And so what we're going to do is you take the antiderivative of the function that we're looking at, and then we plug in 0 and then 4, and then we go from there. And that's how we find the area under the curve using an integral. So first off, we take the antiderivative of the function. So the antiderivative is 1 over 5 t to the 4th minus 1 over 4 t cubed plus 1 over 5 t squared. And our domain is still 4, 0. So then what we do is we plug in for 4, and then we subtract everything plugged in for 0. When we plug in for 0, we just get 0. So we're just going to plug in for 4. So when we plug in for 4, we get 256 over 5 minus 16 plus 16 over 5. And so when we solve that, we end up with 192 over 5. So that's the area under the curve of that function. So our second one is the integral from 1 to 2 of v cubed plus 3v to the 4th over v squared dv. And so again, we don't have a quotient rule for antiderivatives, so I'm actually going to rewrite this. So we have v cubed all over v squared plus 3v to the 4th over v squared. So this turns out to be v plus 3b squared. And so I'm going to rewrite the integral with this new equation. So integral of 1 to 2 of v plus 3v squared. And I'm going to put this in parentheses, and don't forget the dv. So when we find the antiderivative of this, we have 1/2 v squared plus v cubed from 1 to 2. So we plug that in. So we start with the top and subtract the bottom. So we have 1/2 2 squared plus 2 cubed. And then we subtract 1/2 times 1 plus 1 cubed. So we're going to simplify this and then simplify that. So when we simplify this, we have 1/2 times 2 squared. 2 squared is 4. 1/2 of 4 is 2. So we have 2. And then 2 cubed, 2, 4, 8 plus 8. And then we are subtracting 1/2 times 1 is 1/2 plus 1 to the 1 cubed is 1. So we have 1/2 plus 1, so that's 3/2. So we're going to subtract 3/2. So to further this, it's 10 minus 3 over 2. Get a common denominator. So 20 over 2 minus 3 over 2. Then we get our answer, which is 17 over 2.